Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains what Type 1 and Type 2 errors are and provides practice in identifying them. Let's get started. We've talked previously about Type 1 and Type 2 errors, but we need to put this in terms that we can understand for hypothesis testing. So the type 1 error, which we represent with the Greek lowercase letter alpha, is the mistake of rejecting the null hypothesis when it's actually true. Because we can reject or fail to reject the null hypothesis, and then the null hypothesis could actually be true, which we assume it is, or it could actually be false. If we're rejecting it when it's false, that's great. If we're failing to reject it when it's true, that's also great. But if we reject it when it's actually true, well, if it's actually true, we don't want to reject it. And so that is what we call a type 1 error. We represent the probability of getting a type 1 error with that lowercase Greek letter alpha. Conversely, we can fail to reject the null hypothesis when it's actually false. And that's what we call a type 2 error. And the probability of committing this type of error is represented with the Greek letter beta. So here's how this translates. If we go back to our gender selection example with that XORT method, so what does that actually look like? Well, remember the null and alternative hypotheses that we had for that example. The proportion was equal to 50% for the null hypothesis, and the proportion is greater than 50% for the alternative. So a type 1 error would be concluding the probability of girls is greater than 50% when in fact it isn't. So type 1 error, rejecting a true null hypothesis. So if the null hypothesis is true, then that means the probability, the proportion is 50%. But if we conclude that the probability of girls is greater than 50%, then that's not actually true. So we're going to end up, if we conclude that it's greater than 50%, we're going to reject the null hypothesis. But if it's actually true, we don't want to be rejecting it. So there's a type 1 error. A type 2 error is, you just flip that around, with that you're going to conclude that there isn't sufficient evidence to say the probability of having girls is greater than 50% when in fact it is. So here we're going to say the null hypothesis is actually false. Okay, so the proportion is not going to be 50%. It's actually going to be greater than 50%. But we're going to end up rejecting the null hypothesis and saying that there isn't sufficient evidence when in fact there actually is a higher proportion than 50%. So the way to work these problems is I recommend you basically, in essence, you're just memorizing this table here and then recognizing, what is a type 1 error, what is a type 2 error, and then you go back to your null and alternative hypotheses and you simply apply what you have here in the table to whatever your null and alternative hypotheses are. And you kind of work your way deductively to get to the statement for a type 1 and a type 2 error. In either case here, we obviously need to get better data. And that's where, increasing the sample size, getting more data can help you to minimize the probability of getting a type 1 or type 2 error. Let's look at some examples that we've seen before and see if we can identify the type 1 and type 2 errors. So to start with, a type 1 error, the mean income for entry-level engineers is claimed to be more than $35,500. Identify the type 1 error. Okay, well, let's just walk through this. Again, we have to figure out first, what is a type 1 error? And if you go back to the chart, the type 1 error means that H0 is actually true, but we're going to reject it. We're rejecting a true null hypothesis. Okay, so at this point, we say, okay, so what's the null hypothesis? Remember, our null hypothesis is that the mean value is equal to 35,500. So if this is actually true, then that means the mean is going to be 35,500, but we're rejecting it. Okay? And so that, since we're going to reject that null hypothesis when the mean income is actually equal to 35,500. Because if H0 is actually true, that's going to be the mean value. So that brings us to the correct answer, which is answer option D. Rejecting a true null hypothesis. Okay, rejecting the null hypothesis. There's the rejecting part. When that the mean income is more than 35,500, when it's actually equal to. That's the null hypothesis part here, that it's actually equal to. Okay, so there's your type 1 error. What would the type 2 error be here? Well, okay, again, go back to the same process. What is a type 2 error? Here we're going to say a type 2 error is where we're, H0 is actually false, but we're failing to reject it. Okay, so what actually is the null hypothesis? Well, again, the null hypothesis is that the mean is 35,500. So if this is actually false, that's like saying we're going to quote unquote accept the alternative. So, H naught, is H naught, the mean value is actually more than 35,500, but we're going to fail to reject the null hypothesis when that's true. So it's going to be different than 35,500. So if we look at our answer options here, the one that best matches that is going to be answer option B. We're failing to reject the null hypothesis when that mean value is actually different than 35,500. How do we control type 1 and type 2 errors? Well, for any fixed sample size that we represent with n, okay, we decrease alpha, we're going to cause an increase in beta. And you can look at it as like, you've got two distributions here for each of your hypotheses, and you've got one for the null, and then there's a theoretical non-null value, which really our alternative hypothesis is what this distribution is representing. And if you take a mean value that we're going to actually compare with our claim, okay, that's going to represent a certain spot inside each of these distributions. And it's going to create tails in each of those distributions. This is where the type 1 and the type 2 error come from the tails created by the value that we select for our claimed value. So in this case, you can see that if we shift one of these distributions over, okay, so if this one on the right shifts to the right, okay, we're going to make the type 2 error, we're going to make that smaller, but at the same time, we'll actually end up making type 1 error larger, okay, and a decrease in alpha will cause an increase in beta, so it goes both ways, okay. For any fixed alpha, so if we fix the size of this tail, okay, then we can get, by changing the size of the distribution, we'll just change the sample size to change the size of the distribution, and that's going to give us a decrease in beta. And the converse is also true. For any fixed beta, increase in the sample size will give us a decrease in alpha. So how do we decrease both type 1 and type 2 errors? Because it seems like if you increase one, you decrease the other. And the way you get that is you've got to increase your sample size. Increasing the sample size gets you more data, and it helps you to minimize both the type 1 and the type 2 errors that you see. So this is one of the reasons why we're always pushing for more data, because it decreases the chance that we're going to commit one of these type 1 or type 2 errors. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.